Good day everyone, so welcome back to my YouTube channel, and today we are now in analytic geometry and we're going to talk about distance formula. Welcome to Kasaligan Vlogs. So distance formula is the undirected distance between any 2 points P1 and P2 in the plane. It is also used to denote the length of the line segment P1 and P2. In using distance formula, it makes no difference which of the two given points is denoted by P1 and which is denoted by P2, since for any AB is an element of R. We know that A minus B quantity squared and B is equal to the quantity of B minus A squared. So this is the distance formula. So D is equal to the square root of the quantity of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That is y sub 1 squared. Okay, let us make a correction. This is y sub 1 squared. Alright, so we have now how the concept of distance formula. So we have to think of the definition. So let us have first how we come up with this distance formula. Alright, so we have here, if we have here the plane, so let us assume this is a plane. Okay, so if this is the point here, point 1, x sub 1, y sub 1 here, and this is the point going up, okay, and this is our point 2, x sub 2, y sub 2. Alright, so if we are going to extend this one here, and also if we're going to extend here, it will create a perpendicular lines or two intersecting line, which creates a perpendicular angle. So we have here, if we extend both sides here and extend here, so we could create now the distance between the 2 points. So we have here the distance. In order for us to get the distance between these 2 points, so we're going to get the distance of this x and this y. And this is the distance d. To get for that one, because we could now use the Pythagorean theorem. So we have here, if this is d squared is equal to x squared plus y squared. So now this is the distance that we're going to get. But what is the distance of x squared and y squared? So what is the coordinate? So let us have first the coordinate of this one. So to get the distance, we have to subtract. So this is x sub 2 minus x sub 1 here. And also for the y part, if we're going to extend here the y part, so we need to get for y sub 2 minus y sub 1, because this is in terms of y. Okay, so again, this is in terms of y and this is in terms of x. So we have here the result of this one. This is a triangle. So to get the distance of this one. So now we have here d squared is equal to this. We can have this the square root of this part, and to get the square root of this part, so x squared plus y squared. So therefore d is equal to the square root of, what is the value for x squared? So our x is the value for is x sub 2 minus x sub 1. Okay, then squared here plus y sub 2 minus y sub 1 squared. So now we come up with the distance formula. So it is absolute because we're just going to get the distance of this part, the undirected distance. So that's the concept behind distance formula. Alright, so let us now have problem number 1. So based on the definition, we'll have to apply the definition. So find the distance between the 2 points, negative 3, 1 and 9, 6. So based on the definition, we cannot say that this is a point 1 and this is point 2. So it could be interchangeably used. So this is again, it could be point 1 here, this is point 2, or if this is your point 1 or this is your point 2. So let's try both. So the formula for D is equal to the square root of x sub 2 minus x sub 1 squared, then plus y sub 2 minus y sub 1 squared. So our D here is equal to the square root of, if we make this one as our point 1 and this is our point 2, so this is x sub 1, y sub 1, and this is x sub 2, y sub 2. So the point here is x sub 2 here is 9. So 9 minus, and this is our x, and this is our x here, x sub 1. So negative 3 squared. So still this is a negative, then squared. Plus, we have here y sub 2, which is 6. So 6 minus 1, which is the y here, squared. So D is equal to the square root of, we have to simplify first, 9 plus negative 3, then square. 9 plus 3, oh this is not square here, this is square. 9 plus 3 squared plus 5 squared. So D is equal to the square root of 12 squared plus 25 squared. 25 rather. So this is 12 squared. So D is equal to the square root of 144 plus 25. So 144 plus 25 is the square root of 169. So therefore this is 13. So take the positive since we need to get the distance. If we are going to make use this one as our point 2 and this is our point 1, yes, still same answer. So D is based on definition. So this is equal to the square root of, so this one would be now our x sub 2 and y sub 2. This is our x sub 1 and y sub 1. So how to get x sub 2, which is negative 3, minus, which is 9, then squared, plus we have y sub 2, which is 1, minus 6, then squared. So D is equal to the square root of negative 12 squared plus negative 5 squared. So D is equal to the square root of 144 plus 25. So this is the square root of 169. So D is equal to 13. So based on the definition, it's up to you what is your point 1 or point 2, as long as we have the same answer. So let's find the distance between the 2 points. So let's proceed with number 2. Find the point on the x-axis that is equidistant from A, negative 2, 3, and B, 10, negative 6. First thing that we're going to do is we are going to graph. So graph here. Oh, okay. So we have, okay, so we have to assume this one. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1, 2, 3, 4, 5, and 6. So the first point is negative 2 and 3. So this is the point A. So negative 2 and 3. And B is 10, 10, negative 6. Okay. So this is 10, negative 6. This is our B. Okay. So find the point on the x-axis that is equidistant from A, negative 2, and 3, and B. So both here, we have to find the point here in the x-axis. So when we talk about x-axis, so the y is equal to 0, right? So the point now here is 1, 2, 3. We have to locate the distance here that is equal. So let us assume that this is here and this is the point here and the x-axis. So this is the point that we're going to talk, but we assume that this is here is the point. So if this is our d1 and this is our d2, as what's stated in the problem, that this distance here and distance here are equal. So therefore, d1 is equal to d2, base equidistance here. So now, to get the equidistant, so we have here the third point, which is x and 0, that is on the x-axis. So we have first, if this is our x and 0, so first we have to find the distance here and equate it with the distance here. So let us first this part. So d1, the square root of, right? So the square root of, so let us assume this is x minus negative 2, then squared. Here, x minus negative 2 squared plus 0 minus 3 squared is equal to the square root of, here, x minus 10 squared, and x plus 0 minus negative 6, then squared. So they have to substitute here, x plus 2, then squared, plus 3, negative 3 squared is equal to the square root of x minus 10 squared plus 6 squared, because this is positive. Alright, squared. So by the use of the property, we have to square both sides here. Okay, so this is x plus 2 squared by algebra plus 9 is equal to x minus 10 squared plus 36. Expand, we have x squared plus 4x plus 4 plus 9 is equal to x squared twice the product, 20x plus 100 plus 36. Alright, so we have here, cancel this part. Alright, cancel. So we have 4x plus 13 is equal to negative 20x plus 136. So combine here. So combine all the terms here. So we have 20 alright, so 20, this would become 4x plus 20x is equal to 136 minus 13. So 24x is equal to 136 minus 13, that is equal to 123. So therefore x is equal to 123 over 24. If we're going to simplify that one, that is equal to 41 over 8. So that is equal to 5 something. So 5.125. So here, 1, 2, 3, 4, 5 here part here. So the x and 0 here is 41 over 8 exactly on 0. So this is now the point on the x-axis. So that's all for number 2. Number 3, if 1 negative 2 is equidistant with 4, 4 and x 4, find x. So first is we need to graph. In analytic geometry, you need to graph before you're going to answer. Okay, I need a graph. Okay, so if 1 negative 2, so we need 1. Okay, we'll make here 1 negative 2, 1 negative 2. So this is the point. And 4, 4. So 4 and 4. Is equidistance. If 1 negative 2 is equidistant with 4, 4 and x 4, find x. So this is x 4. So let us assume that our x in 4 here is here. X 4. Okay. So we don't know where's the here. Sum here. This is our x 4. Okay. So x4 here and 4, 4. So first is need to find the distance that is equidistant here and this one. If 1 and negative is equidistant with 4, 4 and x4, so therefore this is our d1 and this is our d2. So d1 and d2 are equal at the side because this is equidistant. So now we get the distance between the two. Our d1 is 4 minus 1 squared plus 4 negative may maging 2 squared is equal to the square root of x minus 1 squared plus 4 maging plus minus, so plus squared. Okay, so this is a square root, so we have to square both sides. Alright, so this is 4 minus 1, 3 squared, that is equal to 9. Then square root 9 plus 4 plus 12, that is equal to 30. 4 plus 2, 6, 36, that is 36. This is x squared minus 2x plus 1 plus this is 36. So next we have cancel 36. So the remaining is x squared minus 2x plus 1, and this will become minus 8 is equal to 0. We transpose here 9 rather, 9. So x squared minus 2x minus 8 is equal to 0. So factor, so x minus 4 and x plus 2, right? So that means an extreme, so negative 4x, and this is 2x. That's correct. So x is equal to 4 and x is equal to negative 2. Since given an x is equal to 4 here, so therefore we'll choose for x is equal to negative 2. So therefore the value for x is negative 2 here. So this is negative 2 and 4. That is equidistant with 4 and 4. That is equal to, that is number 3. Next, number 4, find the value of x in x4 if this point is 10 units distance from 0, -2. So first is we're going to graph. Alright, so graphing. So find the value of x in x4. Okay, if the point is 10 units distant from 0, -2. Yeah, right. So 0, -2. So we have here -2, 0, -2, going down. Find the value of x, that is x4. So when we talk about x4, so unknown ang ating x, which is 4 here, right? In this side and in this part, right? It could be here and it could be here. That is 10 units distance from here and from here. So it could be here and it could be here, that they have 10 units distance. So as long as the point here, the 4 is in the y, and we need for the value for our x4 here, and also we have our x4 here. Since this is 10 units distance, so we have here our distance formula, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1, alright, squared. So we have here 10 units distance, so 10 then squared is equal to the square root of, we have x sub 2, so we have x sub 2 minus x sub 1. So first is we have x, alright, x minus 0 squared plus y, so 4 plus 2 then squared. So this is 100. So the square root of x squared plus 36. So take the we have to alright, this is squared pala, squared, then squared, naging x na siya. So 100 is equal to x squared plus 36. Again, so this is squared and this is squared. So the square root, natanggal na siya. So therefore, we have here 100 minus 36 is equal to x squared. So we have here 100 minus 36, that is equal to 64, is equal to x squared. So x is equal to square root both sides. So positive and negative 8. So therefore, we can say that this is positive 8 and negative 8. So the points here is find the value of x. So there are two values of x, which is positive and negative 8. So that's all about number 4. So let's solve for number 5. Find the point on the y-axis that is equidistant from 6, 1. Alright, so first thing that we're going to do is we're going to solve and illustrate. Okay, best form is to illustrate so that I could be able to know if you understood the lesson. Okay, just assumption here. Okay, 6, 1. Okay, 6, 1. Find the point on the y-axis that is equidistant. So this is our 6, 1 from 6, 1 and to negative 3. So negative 2 and negative 3. So we don't know the point on the y-axis here. What is here? Let us have here in the point of the y-axis That's the equidistance with this one. So this is our D1 and D2. So our D1 is equal to our D2. So now we have to find the point on the y-axis. So the point on the y-axis is that the point is 0 and y. The x is 0 and the point is going upward, which is our y. So the square root of, okay, there are two distances here, d1 and d2. So let's start with here y minus 0 rather, 0 minus 1 squared plus here y minus 1 squared is equal to the square root of 0 minus naging plus squared as preceded plus y plus 3 squared naging plus because negative. So take the square root by squaring both sides. So we have here negative 1 squared, that is equal to 1, plus y minus 1 squared is equal to, this is 2 squared, that is 4, plus y plus 3, then squared. So let's expand here, y plus y squared minus 2y plus 1 is equal to 4 plus y squared plus twice the product of this one is 6y plus 9. So cancel this y and we have 2 minus 2y is equal to 6y plus 13. So combined here, 2 minus 13 is equal to 6y plus 2y. So therefore, this is 2 minus 13. Alright, so let's check. Oh, this is 6 rather, 6. 0 minus 6. Alright, 0 minus 6, this is 36 rather, 36. And this is 36. Okay, sorry for inconvenience. This is 37. 37 minus 2y is equal to 6y plus 13. Again, this is 0 minus 6. So 2y is 37. So 37 minus 13. So 37 minus 13, that is equal to 24. So 24 is 8y. So our value for our y here is equal to 24 divided 8, that is equal to 3. So therefore the point here in the y-axis is 0 and 3. So this is the point on the y-axis. This is 0 and 3. Alright, so thank you so much for listening for this 1 to 5 problems. And we have you try this at home. So make sure to watch first the videos, and after that one, you're going to solve this as part of your requirements. So try this and so that you will be able to understand fully the concept about distance formula. Two vertices of an equilateral triangle rather are 10, -4, and 0, 6. Find the third vertex. The coordinate of the point P is twice the abscissa. The point is equidistant from -3, 1 and -2. Find the coordinates of P. The sum of the distances from point P to 8, 0 and -8, 0 is 20. If the abscissa of P is 6, find the ordinate. Take note what is abscissa and what is ordinate. X and Y, ordered pair, ordered pair. X is the abscissa, Y is the ordinate, XY is the point, XY is the point. So remember that X is the abscissa and Y is the ordinate. Again, X and Y, ordered pair, ordered pair. X is the abscissa, Y is the ordinate, XY is the point, XY is the point. So thank you so much for listening. I hope you understood the lesson today. God bless everyone and solve at home.